So, welcome to my YouTube channel. Today, I'm going to discuss the measure. See, in my previous video, I discussed the measures of how to calculate the measures of central tendency and dispersion using normal Excel functions in case of ungrouped data or raw data. So today we will be discussing these, like how can we calculate all these measures of central tendency, dispersion, and other measures of skewness and kurtosis using group frequency distribution. So here I have taken a data. I have given the lower class boundary, upper class boundary, and the frequency. And here, so the we can calculate mean first by using this formula summation fi(xi) divided by summation xi. So first we have to calculate the mid value. So what is my mid value? My mid value is basically upper class boundary plus lower class boundary divided by 2. This gives me the mid value. So we drag and drop. Now we'll calculate fi(xi). So it's basically we multiply the frequency with the mid value to get the fi(xi), to get the value fi(xi). And then we'll calculate the total. So this is summation fi(xi) 21625. So my mean will be equal to summation fi(xi) divided by summation xi. So 84.14397, that is my mean. There are other methods to calculate these mean as well. One is the assume mean method. Another one is the step deviation method. So for assume mean method, we calculate, we use this formula. That is, first we take the middlemost mid value and we consider them as an assume mean or A. And then we calculate the DI, the deviation from the mid value, from a deviation of each mid value from this assume mean. So let's calculate DI. So here my middlemost mid value is 85. So we will calculate the distance between each mid value from 85. So this is my assume mean. Next, we calculate the FIDI. So it's basically equal to frequency into assume mean, and then we drag and drop. So then we calculate the total. So now my mean is, so my mid value was 85 plus summation FIDI, which is this, divided by summation Fi, which is the total frequency. So again, we have got 84.14397. It matches with our previous answer. So obviously we can be confident about our calculation. Then we have a third method, which is the step deviation method. Here we use this method. That is, we calculate a value ui, which is the difference between each mid value from the middlemost mid value, which is 85 in our case, divided by class size, which is the difference between lower class boundary, upper class boundary and lower class boundary. And then we use this formula to calculate the mean. So first we calculate ui. So ui is basically equal to mid value minus the middlemost mid value, which is 85 in our case, divided by upper class boundary minus lower class boundary. So this is my ui. So we drag and drop. Then we calculate FIUI. So it's equal to this into the frequency of that particular class, and we drag and drop. Now we calculate the total. So my summation, if I ui is minus 22. Now I calculate the mean, which is equal to 85 plus summation fi ui divided by summation fi into my age was 10 minus 20, which is 10. So we put another bracket. So 84.14397, the value that we calculated earlier. So these are the three methods to calculate mean. First one was the normal method, summation fi xi divided by summation fi. The second one is the step deviation method. And the second one is the assume mean method. And the third one is the step deviation method. So next we move on to median and first and third quartile. We know that median is the second quartile. So here we will be calculating the median, the first quartile and the third quartile. So the formula for median is given here. So it is, first we have to identify the lower boundary of the median class, and next we have to calculate the cumulative frequency. So first we will calculate the cumulative frequency. So for the first, so here it is for the first thing, it's just the frequency. The second class onwards, it's previous cumulative frequency plus frequency of that particular class. And we drag and drop. So these are our cumulative frequencies. And sorry, mistake. This is the first one, and second one is this plus frequency of the next class, and B. So this is my cumulative frequency. Next, we have to calculate the median class. Here, the median class, see, the total number of observation is 257, and so n by 2 is something around 130. Like had it been 260, then it would have been 130. So n by 2 is 128 or 129. So this falls, that particular cumulative frequency falls in this class. So we consider this a median class. So lower boundary of the median class here is, so my n by 2 is 129.5. Lower boundary of the median class is 80. And frequency of the median class is 50. And the class width is 10. So we'll use this for this particular formula to calculate the median. So lower boundary of the median class is this plus n by 2 minus cumulative frequency of the class preceding median class is this 102 whole divided by frequency of the median class, which is 50, whole multiplied by age, which is 10. So 85.3 is my median in this case. So in the same way, I can calculate the two quartiles. For the first quartile, we'll have to, instead of n by 2, we'll be first identifying n by 4. So my 257 by 4 is 64.25, and the 64.25 falls in cumulative frequency 64.25 falls in this class, the green shaded class. So the lower boundary is 60 here, and frequency of that class is 20, and cumulative frequency of the previous class is 47. So first we have written all the information here, that is n by 4, L, H, F, and cumulative frequency of the previous class, which is 47. So next we calculate the median. So the lower boundary of the median class is of this particular class is 60. The n by 2 is this 64.25. Then the cumulative frequency of the class preceding that class is 47, divided by frequency of the median class is 20 here, into width of the class, which is 10, and we calculate the first quartile. In the similar way, we can calculate the third quartile as well. There, instead of n by 2 or n by 4, we'll be calculating 3n by 4, which is 192.75 in this case. And then we identify the lower boundary of the class, that is 100, and we use this particular formula. Just in this median formula, instead of n by 2, we'll be having 3n by 4, and the corresponding cumulative frequency and the frequency of the that particular class to calculate the third quartile here, which is 101.0577 is the third quartile. So this is how we can calculate the median, the first quartile, and the third quartile. We can also calculate the coefficient of quartile deviation using this formula. All these calculated values of just give me a minute. There must be some technical issues. Okay, so next we will calculate the mode. So we have again we have the same formula here. Okay, so next we will calculate the mode using this formula. So here first we have to identify the modal class, that is the class with highest frequency. Then we'll have to identify the lower boundary of the modal class, frequency of the modal class minus frequency of the class preceding modal class, divided by 2 into frequency of the modal class minus frequency of the class preceding modal class, and then frequency of the class succeeding modal class multiplied by the class width. So here my modal class is this one. This 80 to 90 is my modal class. The frequency of the modal class is 50. So here I can write lower boundary of the modal class in this case is lower limit of the modal class, which is 80. Then frequency of the modal class is here 50. Frequency of the class preceding modal class is 35. Frequency of the class succeeding modal class is 38. And H, which is the class width, is 10 in this case. So my mode will be equal to L plus frequency of the modal class minus frequency of the class preceding modal class divided by 2 into frequency of the modal class minus frequency of the class proceeding modal class minus frequency of the class next to modal class, and we multiply the whole thing by h. So this is my mode. So I have calculated the whole value here. So it is 85.5556 should be the value of the mode. I think I made some error here. So I was getting a different value. You can recalculate the whole thing and I'm sure you will get the actual value here. So next we have the measures of dispersion. So we'll talk about the mean deviation about mean, the standard deviation and coefficient of variance. So we have taken the old data only where we have the upper class, lower class frequency, upper class boundary, lower class boundary frequency, and the mid values have been calculated. And we also know the mean. Earlier we have calculated the value of mean, which was 84.14397. So we will be using this value. So to calculate mean, first and foremost, we have to calculate this value, that is absolute value of xi minus mean. So we calculate equal to abs. Abs is basically absolute value. So xi minus my mean was 84.14397. So this is my absolute value of xi minus mean. So now next we have to calculate fi into absolute fi minus x bar. So fi xi minus mean. So we multiply this by the frequency and then we drag and drop. And then we add the whole thing. So next we calculate the mean deviation of mean. So it is basically summation fi into absolute xi minus x bar divided by summation fi. So this is 5425.37 divided by the total frequency, which is 257. So my mean deviation of about mean is 21.11. Next, we calculate the standard deviation. So for standard deviation, we know the form. First, we have to calculate variance. And for that purpose, first we have to calculate the value of xi minus x bar whole square. So xi we know, mean we know that my mean was 84.14397. So we calculate the xi minus mean whole square. So it is basically this minus 84.14397, which is my mean. And then we calculate the square of the whole thing. Then we drag and drop. And next I calculate fi into xi minus mean whole square. So this is basically this into the corresponding frequency. And then we calculate the total. So this is my, if so, summation xi minus x bar whole square is summation fi into xi minus x bar whole square is 1245. So my variance is this divided by 257. So it is basically 1245 by 257. So this is 4.96 is my variance, and standard deviation is the square root of variance. So we write equal to SQRT. So this is my standard deviation. So huh, there was, I think I made some mistake there. So, oh, sorry, there was a mistake. So the summation fi minus x, fi into xi minus x bar whole square is this value, 127811.7. So my variance is this, my variance should be 127811.7 divided by 257, which is 769.69, and standard deviation will be the square root of the whole thing, and we are getting 27.74. Next, we calculate the coefficient of variance, which is SD by x bar into 100. So this is this divided by x bar. My x bar was 84.14397. So 84.14397. And then we multiply the whole thing by 100 to get the coefficient of variation, which is 32.97 in this case. So here we have learned to calculate two measures of dispersion. One is the mean deviation of about mean. We can, since we know the value of median, we can calculate the mean deviation about median as well. We know the values of median and two quartiles. So using appropriate formula, we can calculate the quartile deviation as well. And the most important of all is standard deviation, because it is a measure we often use. So standard deviation and variance, we have seen how to calculate these two measures. And finally, the coefficient of variation, which is the relative measure of dispersion. So next we move on to skewness and kurtosis. We know that to calculate skewness and kurtosis, we can use the moments, and we can also use some direct formula. So we'll be seeing both those techniques now. First, we use skewness using this formula 3 into mean minus median divided by SD. So we previously calculated both mean, median and SD, and we use this formula to calculate the skewness. And for kurtosis, we can use this formula, that is summation fi xi minus x bar whole to the power 4 divided by n into standard deviation to the power n into sample standard deviation to the power 4. So you calculate xi minus mean to the power 4 here. So this is basically okay, here the standard deviation formula, they are using n minus 1. So we have to recalculate sample standard deviation. So we need, first we need xi minus mean whole square, and then we need xi minus mean to the power 4. So here equal to this minus 80. This is my mean, and I'm fixing the particular cell using $sign to the power 2. And next we have this minus mean is this one, and we are again fixing the cell using dollar sign. And then we drag and drop. So first we have to calculate the standard deviation, which is summation. Oh, again we have to calculate the fi into this whole thing. So fi into xi minus mean square, and then we'll calculate fi into xi minus mean to the power 4. So equal to this thing into the corresponding frequency. And again, this thing into the corresponding frequency. And then we add the whole thing. So first we have to calculate the standard deviation, which is this divided by 256 here. This is the variance, and standard deviation will be square root of this thing. So 27.797515. So this is the standard deviation. And then we calculate the kurtosis. So kurtosis will be summation fi into xi minus x bar to the power 4, which we have calculated earlier. So equal to this divided by n is to the power 4. So my n is 257 into this to the power 4. So this gives me the kurtosis, which is the 3.048. So this is the value of beta 2 value of kurtosis. Gamma, obviously, if we deduct 3 from this, we get the gamma 2 value. So next we calculate the raw moments, and we learn how to calculate the raw moments and the central moments. So here we have the formula to calculate the raw moments. So for each raw moments, we have to calculate mid value to the power, like the order of the raw moments, and then we use raw moments of any order using this particular formula. So we'll calculate the first and second raw moment. So my first raw moment is very easy. We know xi, so we'll calculate the fi xi first to get the first raw moment. So this into frequency, we add everything together, summation fi xi. We take the total. So my first raw moment is this divided by 257. So equal to this divided by 257. See, we know that first raw moment is nothing but mean. For this data, we have already calculated mean, which was 84.14397. And the first raw moment is matching with that. So we should be confident about our calculation. Next, we'll calculate the second raw moment. So for that, we first have to calculate fi xi squared. So this into xi squared. Then we drag and drop and we find the total of the whole thing. So this is my Fi xi square. So my second raw moment will be nothing but summation Fi xi square divided by the total frequency, and it is this 7849 minus 903. Now I can use this formula to calculate the variance. So we know the second raw moment. So it is second raw moment minus first raw moment square. So equal to, this is my second raw moment minus first raw moment square, gives me the variance, and the square root of variance is the standard deviation. So this is how I can calculate the variance and standard deviation using the concepts of raw moments. Next, we will calculate the central moments. So again, the central moments formula are given here. So for to calculate any central moment of a particular order, we have to calculate the mean deviation and take that power. Like for first moment, it is xi minus x bar. For the second central moment, we'll have to calculate xi minus x bar whole square, and so on. So here we will be calculating three central moments, because to calculate skewness, we need the third order central moment, and to calculate kurtosis we need the fourth order central moment. So, and second order central moment is nothing but the standard deviation for us. So we will be calculating these values. So let's calculate xi minus mean square. We need to multiply with the frequency. So straight away we will be calculating xi minus mean square, fi into xi minus mean cube, and finally fi into xi minus mean to the power 4. So equal to frequency into my xi is this minus my mean. Mean was 84.14397. I'll just write the value. We calculate the total here. Next, it is equal to fi into xi minus mean square. So 84.14397 square. And then we drag and drop and we calculate the total as well. So this is my fi into xi minus mean square. So my first, so we will be calculating my we'll be calculating my second central moment, which is nothing but the standard deviation, and it is basically this fi into xi minus mean whole square divided by 257. So equal to this divided by 257. And of course, the second central moment is my variance. So we get the variance here, and standard deviation will be root over of the whole thing. Next, I will calculate the third central moment. So it is fi into this minus 84.14397 and this whole cube. And we drag and drop, and then we take the total of the whole thing. So fi into xi minus mean whole cube, and this is my fi into xi minus mean whole cube we have got. Now we will be calculating this measure of skewness. So it is this whole square divided by 1 by n summation fi into xi minus x bar whole square. So this is basically to this if we calculate. So equal to this divided by 257 whole square whole divided by summation fi into fi xi minus x bar whole square divided by this and whole cube. So this is the measure of skewness. See, previously we also calculated the value of skewness, and it was this. And here also we are getting the same value in absolute terms. So the skewness is okay. Beta 1. So next we'll calculate the kurtosis, which is the value of beta 2. So next, for that, I have to calculate summation xi minus mean whole to the power 4 into fi. So this is my fi into this minus 84.14397 whole to the power 4. And we drag and drop. We also calculate the total, which is this, and then we calculate the value of kurtosis. So for that kurtosis, we have to calculate this thing. So this is, we use this formula. So this thing divided by 257 whole divided by standard deviation whole square. So it's basically this divided by 257 whole divided by this one, again whole divided by 257 and whole square. So it is 3.072, and the gamma measure of kurtosis is beta 2 minus 3. So this is 0.072. So this is how we can calculate the central moments and skewness and kurtosis from the same from all those measures of central moments. Finally, we'll be discussing the concept of Lorenz curve. I'll show you how we can derive the Lorenz curve. So here 10 individuals and their incomes are given, 1 to 10, and their individual income is given. I have also included the 0 because we want our Lorentz curve to start from the origin. So next we have to calculate the percentage population share. See, total population is 10. So everyone is sharing 1/10 of the total population. That is the logic. So it should be 1 divided by 10. In any case, you can, so each one is, the percentage population share is 1 by 10 into 100%. So this gives you the percentage population share. So each one is sharing 10% of the total population. In the same way, we will be calculating the percentage income share. So it is individual. See, for the first column, we have 0 everywhere. So we just put 0. So it is basically individual income divided by total income. Again, we'll set this, we will fix this particular cell using the dollar sign into 100. And then we drag and drop. So this is the percentage population, percentage income share for each individual. Then we will be calculating the individual, every individual's cumulative population share. So for the first one, it's just the individual value. Second one onwards, previous cumulative value plus next percentage value, and then we drag and drop. Here the total does not make any sense. In the same way, we will be calculating the cumulative income share for each individual. So the previous value plus the next individual percentage income share. And we add them up. So next we will be showing you how you can calculate the Lorentz curve. So insert, you will be using scatter plot here to calculate, to make the Lorentz curve. Scatter plot with smooth line. You can either use smooth line and markers, or just a smooth line. Here I am taking the smooth line and markers. So we select the data. Here for the first series, we name them line of inequality, line of equality, or LOE, line of equality. See, equal distribution means everyone's cumulative population share should be same as his cumulative income share. So here we'll take the cumulative population share in x-axis as well as in y-axis to get the line of equality. Next, we make the Lorentz curve. For the Lorentz curve, x value should be the cumulative population share and y value should be the cumulative income share. Okay, so this is my Lorentz curve. And then we will format the axis a little bit because we don't want this blank area anywhere. So we format the axis, and the maximum should be, instead of 120, the maximum should be 100 in both the axes, both in x-axis and in y-axis. So here also we'll be formatting the axis, and okay, so this is my Lorentz curve. This is how I can calculate the Lorentz curve. Now we can So next we'll calculate this Gini coefficient. For that we have to calculate the area under Lorenz curve. See, the area under this blue straight line is the half of the whole thing. It should be 50. We have to calculate the area under this line as well. So it's basically for that we use the area of trapezium to calculate the area under this uh, orange line. So it is basically, so what is the area of trapezium? Half into sum of two parallel line into the gap between two parallel lines. So it is basically sum of two consecutive cumulative income share divided by 2 into gap between two consecutive cumulative population share whole divided by 100. And so we calculate the total area here. So this is my total area. And my we have calculated this thing, the basically the area under Lorentz area under this orange curve, and this is the total area under this orange curve, which is 26.50. And now this area A, like I'll just fill this area to make you understand this. Leave it. This area under this in between this blue line and the orange curve is basically area A, which is 50 minus this total. So equal to 50 minus this 26.50, and Gini coefficient is the ratio between area A and this total area below this blue line, which is 50. So it is basically equal to this thing divided by 50. So this is my Gini coefficient. So that's all for the day. So today we have learned different measures of central tendency, dispersion, the skewness, kurtosis, raw moment, central moment, and the last one, that is the lower calculation of Gini coefficient and plotting of the Lorenz curve. So that's it. That's all for the day. Thanks for watching my video. Thank you so much.